Hello guys, so today in this video we are going to learn about Bayes theorem. Okay. Before doing this, you need to be clear with probability, events, conditional probability, conditional probability. Okay, so I suggest you watch the previous videos. Okay, you watch them continuously, make notes, and then you come to this. Solve 13.1, 13.2, and then come to Bayes theorem, because Bayes theorem, it is the application. This is the application of conditional probability. Application of conditional probability. Conditional probability. It is the application of conditional probability. Okay, probability I'm writing PROB. Okay, and it is also called. reverse probability. Reverse probability. Okay, we'll see why. Okay, I'll show you an example, then we will see why it is called the reverse probability. So I will start with a problem example, then we will go to the formula. Okay. So suppose if I say I have two bags. Okay. One is E1, because most of the time we will be using E1, E2. Okay, I have two bags. One is E1, another is E2. Okay, E2. Don't worry, I will do problems on this also. I will make one more video on which I will do problems on Bayes theorem, because from here one question, 6 marks or 4 marks question will be sure in your final exam. Okay, this time syllabus has been reduced, so I think one question from Bayes theorem is sure to come. So 6 marks you can expect from here. So if I have two bags, E1 and E2, suppose E1 is the event of selecting this bag and E2 is the event of selecting this bag. Okay, so suppose this bag has 3 red balls and 4 black balls. Okay, similarly this has 5 red balls and 6 black balls. Okay, now what do? I put them in a big bucket and cover the bucket. Okay, then I pick up one ball from there. I pick out one ball. Is drawn at random. Okay, these are random experiments, so everything, whatever steps you will be taking, that will be in random. Okay, so if I take out one ball at random, so can you tell me how you're getting a red ball? Let's denote it with R. Okay, so you will say you'll combine the red. By your idea, you will see how many red are there by total. Yes, you might say 8 by 18, but this will be wrong. Why this will be wrong? Because see, there are two different bags. Okay, so when you put your bag in, when you put your hand inside the bucket, this is a big bucket. This is your first bag is there and second bag is there. Okay, this is covered and there is a hole here. Okay, so you put your bag. So I don't know which one is E1 and E2. So this is 3 red and 4 black ball. This is 5 red and 6 black ball. Okay, so this is your big bucket and you're putting your hand from here. Okay, so this is your hand, you put it from here. So you will not know which bag you are choosing. So what you will do in this experiment is, first you will choose a bag. Suppose you choose this bag, then only you will put your hand inside the bag. Yes, so that is the idea here. First you will choose the bag. Directly you cannot say 8 by 18. That will be wrong. You need to consider the probability of selecting the bag first and then ball. That is the idea here, that you have to select the bag first. You have to select the bag first, then you will select the ball. So I hope that is clear. Let's write it down, how to write. So if I say probability of R, getting a red ball. Okay, so that what we will do first, select the bag, then select the ball. Yes, so what can happen? You see, first I may select E1, I may select E1, the bag E1. Okay, so probability of getting E1. Okay, probability of getting E1. So I have selected for E1. So what is the probability of getting a red ball from E1? That is probability of red ball, provided I have selected the bag 1. I have selected bag 1, because see, I am saying that I have selected bag 1. So the probability of bag 1 into probability that red is coming from bag 1. That is the probability of selecting a red ball from here. Okay, but when you're putting your hand inside that bucket where these two bags are there, you may put your hand here also. So you cannot leave the probability of this one. Okay, so either you put your hand here or here, or here, or means addition. Okay, so or here, so I will add here. So what I will add now? Probability of selecting the second bag and probability of the red ball coming from second bag. Clear? So that is my idea. Now you can clearly write what is the probability of selecting one bag from these two. I have a bucket. In this you have two bags. Okay. So what is the probability of selecting any one bag? It's 1 by 2. Yes. So this is 1 by 2. What is the probability of getting red from the first bag? That is 3 by 7. Simple. Plus, what is the probability of selecting this bag here? Again 1 by 2. And then what is the probability the red ball comes from here? That is 5 by 11. It's not difficult. Don't think too much. Just think of the problem. Okay? Think of the problem only. Nothing outside. It is these two bags are inside a bucket. So when you put your hand inside this, you will first select your bag. That is 1 by 2 chances there. You can put in this one or you can put in this one. So there is 1 by 2 chance of selecting one bag. So after selecting that bag, you will obviously select red ball. You want to get a red ball. Yes. So that probability you have to multiply here. Yes. It's same as E1 intersection red ball. Probability of finding E1 intersection red ball. That is in conditional probability. Right. So when you solve, you will get the probability of getting a red ball. Right. So probability of getting a red ball is this. But we are not doing this here. We are going to Bayes theorem. Okay. Now there is a question. If I say from this bucket, I have taken out one ball. From this bucket, I have taken out one ball. And that is red. That is red. Please think nicely. Okay. Previously, you were putting hand and finding the probability of red. We are going like this. Probability of finding red. Now I am telling you that I put my hand and I got a red ball. Tell me the probability that it is coming from the first bag. Tell me the probability that red bag came from here. Previously you select the bag and then you select the red ball, right? But here red ball has come now. Now you want to know that it is coming from the first bag. That is called Bayes theorem. That's why it is called reverse probability. Something has happened. Condition, see? Something has happened. With that you need to find other event. Okay, it's basically coming from down to top. Okay, that's why it is called the reverse probability. I hope it is clear. Okay, let's see how we solve this. And remember, one question for 6 months this year is 2020 to 2021. One question is sure from Bayes theorem. Okay. If I say, if the red ball has occurred, you put your hand, you find that red ball has occurred, what is the probability that the red ball is from bag E1. Okay, so this is what we need to find. So in this situation, what do we do? Probability of E1, you read it like this: probability that red ball has occurred, but it is from bag E1. So this is what we need to find, right? This is what we need to find. So can I write this as probability of E1 intersection R divided by probability of R from conditional probability? Can I write like this? Yes. Okay. Now how did we write this intersection part? Can you tell me? Intersection part I wrote like this: probability of E1, right? So E1 has happened. I hope previous video, if you have seen somewhere I have written like this for this. So probability of E1 into probability of the red from E1, and this is probability of R. Okay, so now this probability is called the favorable probability for bag E1, and probability of R we already found here. You can see this is probability of R in this bag. In this situation, this is probability of R, right? So can I write like this? Probability of E1 into probability of a red ball from E1. Okay, you can read it your way. You can say that E1 has happened and red ball. E1 means you selected bag E1 and then you want a red ball. So that is what you are getting. The probability of R was probability of E1 into probability of R given E1 plus probability of E2 into probability of R given E2. See, this is total probability. So what you were doing in class 11, favorable probability by total probability is the same thing. Yes, this is the probability of getting red ball from E1. That is what you are finding. So this is favorable to red ball from E1, and this is the total probability. Total probability of getting a red ball. Yes, I hope this is clear. So suppose if you have n events. So if we have E1, E2, like that, En event. Okay. If we have E1 mutually exclusive, let me write it properly, because mutually exclusive and collectively exhaustive events. Okay, an event A which is common to all E1, E2 till En events, okay, has occurred. The probability of A happening with any of the E1, E2 till En events is, okay. So suppose, see, there are E1, E2, E3, E4, E5 till En. These are events, okay. E2, E3, dot. So this is some E. Many are there. Okay, and this is E. So this is event A. Okay, this is event A. which is common to all of them. Now if I ask you what is the probability of A happening from E3, okay, then we use Bayes theorem. What is the probability of A which has occurred, but it has occurred from E3? Okay, or if I ask you probability of A has occurred, but what is the probability that A has happened from E2? What is the probability? Or if I ask you probability of probability of A has happened, but what is the probability that it is from EI? Okay, so by Bayes theorem, we can say probability of EI. This is for general, okay, given A has happened. This is what I'm asking here. So, like previous example which I showed you, if I ask you to write what is favorable to this, what is the favorable probability for this? What is the favorable probability for this? If I tell you to write, you will write what? Probability of EI intersection A, right? And how do we write this? Probability of EI into probability of A, because EI has happened, so EI. This is how we will write. Okay, so this will be the favorable probability for this. So how do we write this one and the probability of this one where EI has happened. EI has happened. Okay, by here. So in the next slide I will be writing. Okay, this is favorable. This is favorable because you want A to happen and EI also to happen. Basically, you are thinking this part to happen. You are wanting this part to happen. This one, this part, right? So EI intersection A. Okay, you want this part to happen. So that is this favorable to this. So favorable to that event is this probability of EI intersection A by total probability. Total probability of A happening. Okay, we want the probability of A happening from E1. We want the probability of A happening from E1. Okay, so that will be favorable by total probability of happening of A. Yes. So what is the probability favoring to A happening from E1? This is, yes, we will see how we write down. Okay, and total probability of happening of A. So we will see probability of EI multiplied by probability of A given EI. Okay, and total probability, what is the total probability? A can happen, see, A can happen from E1 also, this part. A can happen from E2 also, A can happen from E3. Similarly, it can happen from all of them. So I will write, similarly like previous one, we need to write total probability. So probability of E1 into probability of A from E1 plus probability of E2 into probability of A from E2 plus probability of En into probability of A from En. Okay, so that is what I will have as formula here. So now this you can remember, probability of EI given A. Okay, and in your books it's written like this, probability of EI given A will be written as probability of EI into probability of A given EI summation, the summation I equals to 1 to n, I equals to 1 to n, probability of EI into probability of A given EI. This is how you write your Bayes theorem. So what you have to remember is any one of these two. So this one or this one, any one of these two you have to remember. Okay, remember total probability of that. Now let's see an example. That will be it, and in the next video I'll show you problems of this. and that will clear your base theorem, and I think you should get 6 marks from this. Okay, explanation, please watch it carefully so that you develop some idea to solve the problem. Okay, so you will see those tricky questions here. Okay, 3 identical bags are there with you. That means one bag here, another bag here, third bag are here. Okay, containing 2 red balls, 2 red balls, 2 black balls, and one red and one black ball respectively. So 3 bags, bag 1, 2, 3. These 3 bags are there. In that, in then the balls are like this. Okay, a box is drawn. Let's make it bag. Okay, a bag is drawn and a ball is drawn from it at random. Okay, so first you will select any bag from here. You put in 3 bags are in a bucket. You take out one bag and from there, but you don't see which one it is. Okay, that is the question. So you take out the bag, you take the bag, and from there you draw a ball. A bag is drawn and a ball is drawn from it at random and found to be black. The ball which you take out, you don't see the bag. You just select a bag inside the bucket, you put your hand inside the bucket, you put your hand and you put your hand in one of the bag and take out a ball, and you see that that is black. Okay, then they are saying what is the probability that other ball in the bag is also black. Other ball in the bag is also black. Now see here, one ball you take out, that is black. Can you take out black from here? No, so obviously this is not in the picture. Okay, can you take out a black ball from here? Yes, you can take out. Can you take out a black ball from here? Yes, you can take out. Okay, but in the second time, other ball in the bag is also black. So other ball in the bag is also black. That means they are talking about this bag, bag number 2. They are talking about bag number 2 because the other ball is in the bag is also black. Here, if you have taken out one black, the next one cannot be black. Here, so they are talking about getting a black ball from this bag. I hope it is clear. Okay, the question is complicated. The question which is asked is making it complicated. What is the probability that other ball in the bag is also black? That means they are asking the probability of this bag. Okay, one probability of black ball has occurred, but it is coming from the second bag. This they are asking. Okay, this they are asking. One black ball has come, but what is the probability that other ball in the bag is also black? That means they are talking about second bag. Okay, they want the probability of second bag. So I hope this is clear. With this we can start. Okay, so I will keep this diagram. Okay, but tell me, before selecting a ball, you have to obviously select a bag, right? So the probability of selecting a bag will be how much? They are identical bags. They are identical bags because when you put your hand inside the bucket, you should not know which bag is which. That will be biased. Okay, so 3 identical are there. So from them, selecting this bag probability is 1 by 3. Selecting this bag is 1 by 3, and selecting this also 1 by 3. So I hope that is clear. Okay, so what I will do, I will define the events of choosing a black ball from this, choosing a black ball from this, choosing a black ball from this. Okay, so let's see. Please be with me, try to understand. We will apply this in other problems also. Let E1 be the event of choosing bag 1. Okay, so the probability of this E1 is the event of choosing this bag. You put your hand inside the bucket, choose this bag. Okay, then E2 be the event of choosing bag 2. E3 be the event of choosing bag 3. Okay, so that is what we have to define first. Okay, so you have to look the problem in steps. Okay, so whenever you are choosing a ball, what you will do? First select the bag and then you select the ball. So try to break every problem in this way. So now what is known to us? A bag is drawn and a ball is drawn from it at random and found to be black. Okay, so let's define that, and you have to define what has happened. You have to define. So let A be the event that ball drawn is black. Okay, means you have drawn a black ball. Okay, so now what we need to find? So to find the other ball, first ball you have taken out black. Okay, you have taken out black. The other ball is also black. That means this one. Okay, so the other ball drawn is also black. Also black. That is we want back to. We want back to. Okay, so how do we write? Probability that I pick back to, given that I already got a black ball. Okay, or A is our event that black ball is drawn. So this, we need to find this. I hope you agree with me that we need to find this, that probability of picking back to, provided first ball is black. Okay, so what is the probability favoring back to? That is probability of back to multiplied by probability of getting a black ball from E2. This is what. This will obviously, you will write it like this, E2 intersection A, right? So from that I have written this. So you can clearly go to this if you have watched the previous video. I total probability. How do we write total probability? So probability of E1 multiplied by probability of getting black ball from E1 plus probability of E2 into probability of getting black ball from E2. Okay, if you can understand how I'm reading, that will be very nice. Probability of E3, back 3, okay, into probability of getting a black ball from back 3. Okay, probability of getting a black ball from back 3. Okay, so mark this one as 1. Okay, this equation as 1. Now let's find all of them. Okay, so you can see here probability of getting E1. What is the probability that I select back 1? That is 1 by 3. Probability of getting E2, probability of selecting back 2 is 1 by 3 again. Probability of selecting back 3 is 1 by 3 again, right? Probability of, so what I am done with from the formula, I know this, I know this, I know this, I know this, I know this. Okay, now I need to find this one, black ball from E2, black ball from E1, black ball from E3. So what is the probability that I get a black ball from E1? Look here, how many black balls? 0 by 2. 0 by 2, that is 0. Probability of getting black ball from E2, that is 2 black balls out of 2, so that is 1. And probability of getting black ball from E3 is 1 by 2, right? So I hope these are clear. Okay, we just need to substitute them in the formula. Okay, so first you write down the formula and then you find all these and put it in the formula. So from 1, probability of back 2 provided black ball has come. Okay, so what is the probability of E2? E2 probability is 1 by 3. You can see here If you're writing, it's clear. Probability of E2 is this, and probability of black ball from E2 is 1. So into 1. Into 1. Similarly, I'll write the probability of all of them. Probability of E1 is 1 by 3. The probability of getting a black ball from there is 0. Probability of E2 getting the bag E2 is 1 by 3, and probability getting a black ball from there is 1. Plus probability of getting the third bag is 1 by 3 into probability of getting black ball from there is half. So this is 1 by 3 by 1 by 3 plus 1 by 6. So this is 1 by 3, and you will see if you take LCM, 6 is the LCM, so 2 plus 1, 3 by 6. Okay, so you can see 1 by 3 into 6 by 3, 2 times. So this is 2 by 3 is your answer. So this is how you solve the Bayes theorem. Okay, so please see the video nicely and remember this formula very nicely. This one, okay, this one, and this one you wish to remember, but this is more important. Okay, with as many n events you have, then it will go till 10. 5 it will go till 5. If it is 4, it will go till 4. Okay, so these two you have to remember, and the whole video is about understanding Bayes theorem. So I hope it is clear to you. The next video I'll bring with the problems on Bayes theorem. Thank you.